Alright students, I had assigned some problems for you to do. I wanted you to rearrange the above equation, this one here, force of gravitational attraction equals g times the mass of one body times the mass of a second body divided by the distance between them squared. All you're doing is rearranging the equation here, which is called a permutation, because the overall relationship is still true. That's why it's a permutation. Even though the equation looks different, it is still the same equation if you solve for another variable in the equation. It's the same equality, it's just moved around. So here, if we're going to solve for g, what we're going to need to do, I usually draw arrows to make sure that you understand this. G goes to, if we're solving for g, we're going to have f equals g m1 m2 over d squared. The first thing that we're going to need to do is multiply d squared on both sides. So I'm going to put a d squared here. I'm going to put a d squared here to cancel on this side of the equation. So now we have d squared times f equals g times m1 times m2. If we were to write that cleaner, this is what it would look like. D squared f equals g m1 m2. So this was step one. Step one. Now this is step two. Let's do the final step, which is to take d squared times f equals g m1 and m2, and we're going to divide both sides of this equation by m1 and m2. So to do that, divided by m1 divided by m2 divided by m1 divided by m2, m1, m2 cancel out, and now we've solved for g. G equals d squared times f divided by m1 divided by m2. So your final answer equals g equals d squared f over m1 m2. Now let's solve for d. D is a little bit more complicated. As a matter of fact, because it's more complicated, I'm going to come back and let's do M2 and M1. So M2 is going to equal, going back to our original equation up here, we have F. I'm going to multiply both sides of this equation by D squared. I'm going to do it up here. It makes sense to do it up here. So here's my equation. I'm going to multiply it by d squared on both sides. That d squared cancels that d squared. And now I'm trying to get m2, so I'm going to divide this away, m1 times g. So g in the denominator and g in the numerator cancel, and m1 in the denominator and m1 in the numerator cancel. But I have to divide this side also by m1 and g. Because remember, you can't do that on this side of the equation without doing it on this side of the equation. So now we have m2, if we were to write this a little bit cleaner now, m2 equals d squared times f over m1g. So I'm going to write that here. M2, and here I'm just writing it flipped around. We solved it for here. If you flip this, it's the same thing. M2 equals f times d squared over m1g. Let's solve it now for M1. I'm going to erase this work up here. Now let's solve this equation for M1. Here's M1, so to get rid of d squared, I need to again multiply both sides of my equation by d squared. Now, this cancels away, and I'm left with d squared times f equals g m1 m2. So we need to get rid of g and m2 because we're solving for m1. So to do that, let's divide g times m2 on both sides of my equation. G times m2, and g and m2 cancel out over here because they occur as multiples or factors in my numerator and denominator. So what's left is d squared times f over g times m2 equals m1. So let's write that cleaner down here. F equals, m1 equals f times d squared over g times m2. Now we need to solve finally for d, which is the most complicated of this because it does involve square rooting. So let's erase all this. All right. So we need to get d by itself on one side of the equation. The first thing that we need to do is multiply both sides by d squared. D squared cancels here on this side of the equation. And now we have d squared times f equals g m1 m2. Let's divide both sides of this equation by f of gravitational attraction, f of gravity, and f of gravity. This cancels out on this side of the equation, and now we have d squared equals g m1 m2 divided by f, force of gravity. How do we get d by itself? This is really simple. Take the square root of both sides of this equation at this point. Square root of something squared gets rid of the square, and all of this will have the square root of it. So d equals the square root of g m1 m2 over fg, the force of gravitational attraction. And that's your final answer. If you want to put these in parentheses, you can. All right, hope that helps rearranging equations a little bit.